6/9 now. Didn't make any mistakes there, did we? Hey folks, welcome again here at T and Learn Mathline. Specialized segments, and it's summer school time. We're so glad to have you tuned in this afternoon with us. I'm Ernie Roberts. I'm your host for this afternoon's session. And you know, it's been summer school and we're doing a lot of remediation. So let's talk about it. Let's see where we're going today, guys. What is the topic? What is the storyline for today's show here? Summer school, as we say there, is fraction action. I like fraction action. I love fractions because they are our friends, all right? So friendly, fraction action, part one, comparing fractions. You say, what do you mean by comparing fractions, Ernie? Well, we're going to say maybe they're the same, maybe they are a less than or a greater than relationship between two fractions. And you know what? We might put three or more up there and get them in order, maybe least to greatest, things like that. Comparing, we're going to look at them head to head and see how do they relate to each other, all right? Got three options. They can be less than, greater than, or what's the other one? Yeah, they can be equal, right? Less than, greater than, or equal. Those are your three options. Sometimes known as the trichotomy property, but one of those three has to be true as long as they're real numbers, as long as they're real numbers. So we're talking fractions. They are real, folks. They are real. Let's look at an illustration, all right? Let's take a look at our first problem here that we've got set up. And it says, using the rectangles below, we want to show that 6/8 is equivalent to 3/4. Now, notice I've got, well, let's just number. We'll make it easy on ourselves, all right? 1, 2, how about it? 3, 4, 5, 6. Everybody's going like, we can count. Yes, I can too. There we go. We've got 8 of them, all right? And if I were going to look at 6 of these, 1, 2, 3, well, how about it? 1, 2, 3, 4, 5, 6. Those 6 look great to me right there, that little pocket. The question is 6 out of 8. Now notice, tried to, and I think I did pretty successfully here. I believe all of you would say, oh, wow, you did pretty good there, Ernie. But we have made these into equal spaces, all right? Equal rectangles. So we got 8 rectangles here, 8 small ones, that make up the whole big picture. Now, what it says, let's show that 6 out of those 8, that's what that means. By the way, 6/8, that simply means 6 divided by 8, or 6 out of 8, is going to also equal 3 out of 4. Now let's play the big picture. Don't look at just 3 and 4 there. Some of you go, is that what we mean? No. What we mean is that if we were to make big rectangles, and I'm going to do this, notice how my fingers did that? 1, 2, 3, 4. If I were to shade, and that's what I'm going to do here, so to speak. There's 2 of them. I mean, that's one of those 4, all right? Here's a second of the big 4. And then we'll go one more notch here. Now, if you'll notice, we started out in the black there, we started out with 6 out of 8. But when I started pulling these together, I could also look at this as being 1, 2, 3. Watch my fingers, or watch my pen. 1, 2, 3. That's also the same thing as saying 3 out of 4. Now, if you look at that, I'm saying they're equal to each other. I'm saying they're equal to each other. Why? Why am I doing that? Because, real simple, isn't it? Shade a big picture, shade a big picture, shade a big picture. There were 3 of those, 3 out of 4. It's the same space as if I were to look at 1, 2, 3, 4, 5, and 6 all together at the same time. Now you say, Ernie, is that okay to do? Well, certainly it is. Certainly it is. So let's see what we did. If we start out with 3/4, what we did to get to 6/8, we multiplied the numerator by 2 and we multiplied the denominator by 2. Because basically what we did, we doubled the amount of squares when we went to the 8s, right? So here we go to 6 over 8. You know, I could do that again. I could double all of these strips through here and end up with 4 within each of these little blocks, or 2 within these blocks, and so all sorts of things. But I would still have the same relationship that we're basically doing 3 out of 4. 6 out of 8 is the same. If I wanted to go one more notch up, I could take it up to, oh, wow, 12 out of 16. They're all the same. They're representing the same part of this whole big rectangle, all right? We're only worried about 6/8 according to this problem and our 3/4. But notice they are. They're covering the same amount of shaded space. Written differently, we call this lowest terms. In other words, we've reduced it to lowest terms, all right? In this case, 6/8 is still 6 out of 8. Same thing as 3 out of 4. It's also the same thing as 12 out of 16 if we were to reduce those ratios or those fractions all the way down. So that's what we're playing with today, folks. Equivalence. Remember I said there's one option is equal. Other options are what? Less than or greater than. So let's go to our next problem here. If we can go there. Thank you, guys. And let's take a look at our next set of rectangles. We're not going to do a lot of these. I just want to do a couple of these with you. So this time I've picked up a little picture here with, looks like 10 of them. 10 of them all happy and stuff here. So let's put numbers on it. Keep up with them. How about we got 1, 2, 3, and 4, 5, 6, 7, 8, and we'll go with 9 and 10. I don't like numbering them out that way because I'm going to look at it from a vertical standpoint. Now, again, we have 10 basically equal spaces with these little rectangles. They've got the same amount of area inside there. We're going to pretend and we're going to say, actually, I think they look pretty equal to me, very much so. But the idea is we want to show that 6, see 1, 2, 3, 4, 5, 6 out of all those 10 is the same as if we were to say 3 out of 5 in the big picture. You say, what do you mean, Ernie? What do I mean? What do I mean? Let's go another color here. Let's see if this will work better. Let's play it off here. Big picture. All right, we're going to let, because I see 1, 2, 3, 4, 5 rather long pieces there. All right, so let's do another one here. Another long pieces there. All right, we've done 2 out of 5. Let's do one more long strip here. 1, 2, 3, 4, 5. There's number 6. And look what we've got. We've got the same amount of space if we were to say 6 out of 10 when we're looking at all the little rectangles. And then these little ones, I would say they're still, but they're a little bit bigger. These little bit bigger ones here, this strip here, here, and here, we're now at 3 out of 5. And you know what? They are the same. Now, let's talk about this a little bit. How do we get from 6 out of 10 to 3 over 5? Well, we divided both by 2. We divided the 6 by 2, and we divided the 10 by 2. That got us to 3/5. Now, I could have played the other side of the game here. I could have started at 3/5, and if I multiplied both numerator and my denominator by 2, you see what? I'm back to 6/10. And as long as we keep that in the same vein there, in other words, we keep doing the same thing in the numerator that we do in the denominator, I can make a lot of equivalent fractions here. I was asking about 6/10 and 3/5. They are equal to each other. They mean the same portion of the whole, okay? The same portion of this whole big rectangle, all right? So I hope that helps you see a little bit of why we can reduce things, why we can move things. And sometimes, why do we need to enlarge? Because when we're going to add fractions, we've got to enlarge the fraction, so to speak. Now, the size of the fraction per se is still the same. But the numerator and the denominator have increased proportionally, all right? They've increased by the same amount, or in this case, they decreased by the same amount. That's the idea of reducing our fractions and finding, hey, are they equal? Those two certainly are. They certainly are. So what we're going to look at today, word comparing, we're going to decide which one's greater, and when we've got a few, maybe we can put them in good order, all right? So let's take a look at our first problem here that we're asking, which is greater? Now, sometimes, Ernie Roberts is known to trick people, right? Sometimes I'll do that. So it could be not only just a greater or less than situation. Remember, I might throw one in there that's equal. So just be alert to that at home, all right? So you're going, trick question? No, just make you think, just making you think. So let's take a look at this. Go ahead and write these at home while we're there. I've got 11 over 16, and I've got 3/4 here. Now, the whole point of what this exercise is about, what the show is about today, is getting you to be able to transition to the point where these denominators would be one and the same. Because looking at that 11/16, unless I knew automatically what that was, and in my mind I usually can, and 3/4, I already have an idea which one is going to be the greater of the two fractions, all right, have the greater value. Now sometimes I know students say, oh, it's easy. The 3 and the 4 are smaller. That means it's less. So 11 over 16 is greater. That's what you're thinking, all right? Well, let's look and see how that theory works or how it doesn't. But remember, what I need is I've got to have some way to basically compare these things equally, so I need the same denominator. I need the same denominator. So here's my story. I need a 16 instead of a 4. Now, notice 4 goes into 16 evenly. That's why I know I need a 16. That's why I know that I need a 16. So, the question is, how many 16ths is 3/4? We're going to figure that out. So, to get to this 16 right here, we multiplied by 4. We multiplied by 4. And remember what I said, when we change a fraction, we can't just change the denominator. We've got to change the numerator also. We've got to multiply that 3 by the same amount. And that's what we're going to do. We're going to multiply it by 4. Right there we go. Everybody with me? Got it out there? And notice what happens. We now have 12 16ths. I think I mentioned that in the last frame over there, or one of the first ones maybe, when we had the 8ths and the 4ths. I said we could go also to 16ths. And we could go on higher than that. But what we got here is we have a match now. So I have 11 16ths. That didn't change. It was good shape. Now I have 12 16ths. And those of you who thought 3/4 was smaller, guess what? You're not right, are you? This time, we're going to put a less than right in between there because 11 is smaller than 12. So which one is greater? 12 over 16, which means 3/4 is the match. 3/4 our match. So that's what we're looking at today. We're going to think, how do we get the denominators the same? And then it's easy to compare. You just look at the numerators and is one larger? Is one smaller? That's easy to tell, right? Of course it is. Called counting, right? It's called counting. So let's look at a few more of these. That's what we're going to have fun today with, all right? So lay back, relax, let's do some math, all right? Take a next problem out here. What have we got? We've got 2/3 or 5/9. Again, sometimes we can get misled by small numbers. I'm going to put my 2/3 there. Over here, I'm going to put my 5/9. The question is, can we make these have the same value? Yes, can we make those have the same value in the denominator? Now some of you are going, 27. 27 is fine. And for this exercise, it would work fine. But we can even do better than that in terms of size here. Looking for a least common denominator. We have 9 looking at me because I know 3 will divide into 9, and you guys know that too. It goes in there evenly, all right? So what do I need to do? Well, I need to multiply this side by 3. That denominator goes by 3. This one's okay, leave it alone. But remember, if we do the denominator by 3, we got to do what? We got to multiply our old numerator by 3. Don't forget that. Multiplying it through. I'm seeing 6/9 now. Didn't make any mistakes there, did we, ladies and gentlemen? No, nope, nope, nope. And we got 5/9 hanging out over here. You tell me which is larger. Remember, I said it's all about counting at this point. 9s are what we want. We want the same number in the denominator. Now we compare numerators. We compare with numbers in the top of our fraction, all right? And it looks to me like this time, looks like the 6/9 is bigger, which means, yep, we go with that. Question asked, which is greater? That corresponded to 2/3. So there you have it. Did you get it right? And it should be just a 50-50 guess. It should be 100%ly. You know what you're going to do with these problems, all right? You know how it's going to work out. That's what we're after today, all right? 100%, right? Want to be 100%. So let's look at our next problem here. Next problem, ooh, throwing a curve at you. You say, well, Ernie, numerators are the same. You're right, they are. Denominators are, they're different. And one doesn't look like it's a multiple of another. Now that means, in other words, I can't divide 2 into 3 evenly. I can't divide 3 into 2 evenly. So we're going to have to look for something both of those numbers will divide into evenly. And let's go ahead, those of you at home, go ahead and write it down there, 1/3 and 1/2. And actually, I hope that from you guys watching Mathline, you've heard me use this expression, benchmark fractions. Both these are fairly much benchmark. 1/2 is in the middle. 1/3 isn't quite there. So you could already say, well, Ernie, I know 1/3 is not as big as 1/2. But let's show why, when we have the same denominator, we can divide these into the same equal parts, so to speak, all right? So number that both of these little guys will go into, you know, when all else fails, multiply them together. And in this case, they're right next to each other. You always want to multiply them together when they're 1 unit apart. That's going to give you the LCD, or least common denominator. So let's do it. 3 times 2, that one's easy. It gives us 6. And we'll put a 6 there. So that's our common ground. Not the numerator, it's got to be in the denominator. It's got to be in the denominator. It's nice that we had a 1 and 1 up there. It's going to change. It's going to change, and it's going to help us, all right? So let's take a look-see here what's going on, all right? 3 goes into 6. Well, let's look at it. We got to multiply by 2, don't we? Those are those goes intos we like to call them, all right? 3 goes into 6 2 times. And if it goes there, we've got to put it in the numerator also. So we're going to have 2/6 on the left. That corresponds to 1/3, remember, all right? Now on the right-hand side, we're going to say 2 divided that into the 6. Well, it looks like we multiplied by 3 to get there. That's what we need to put there. So here we go. Multiply the numerator by 3 also. And looky, and looky again. 3/6, all right? Which one is bigger? It's pretty obvious. 3 is bigger. So we'll put our little less than symbol. That's our bigger one. That tells us there, folks, 1/2. 1/2 is what we're after on that one. And as I said, hopefully with benchmark fractions, you guys understand that enough and you're good with that, all right, that you can see those. But if that had been, let's say, 7/12 and, maybe 5/6, yeah, it'd probably be fairly easy. But how about 4/5 and 5/6? We can get on tighter and tighter up there. And you're just going like, those are not always benchmark fractions. So this is the method. Get it to a common denominator. Then you can look. Then you can look and make 100% correct check, right? Yes. All right, let's see. Speaking of one of those that could be kind of crazy like that, let's take a look at our next one here. It says 7/10 or 2/3. Now again, I noticed something about the 3. 3 is a prime number. And 3 won't divide into 10 evenly. So you know what? We're going to go ahead and multiply 3 times 10 to get a common denominator. And it really will be the LCD on this one. This is going to be our least common. We're going to pick up 30 and 30. Now remember the game plan. What did we do to the 10 to get to 30? Well, we multiplied by 3. What do we have to do to the 7? You got it on the tip of your tongue out there, everybody? Yes, we're going to multiply that numerator by 3 also. All right, everybody with me? Hanging with it, all right? Now over here, magic continues. What did we multiply 3 by to get to this 30? Well, we did by 10. So, Ernie, that makes sense. Well, I hope it does. Hope it does. And let's see where we're going to go with that. We're going to have to do the same thing to that numerator. See what's happening? Now, let's finish the multiplications. I kind of set them up this time, which I like to do because I want you to remember, you said 10 times 3 here, so you got to bring a 3 over here. You got 3 times 10, you got to bring that 10 here. And now we're going to check this out. We're going to check this out. 21, because that's, we know 7 times 3. 2 times 10, that one's easy. That gives us 20. My goodness, they're pretty close, aren't they? They're not that far away from each other. But which one wins out? This time, 21, that is greater than. All right, so there we go. Put that greater than symbol there. And that corresponds to 7/10. And if you think about it, 7/10 is just a little bit further right on the number line than 2/3. All right, so that's our storyline on this one. Man, common denominator makes it a lot easier. Those were really close. Those are really close. And you can get tighter and tighter on those things, all right? So let's remember those things, all right? Good deal. Let's look at our next problem, see what's going on. It says, which fraction is greater? I've got 8/16, or 8 divided by 16, or 8/16, as we like it. And I've also got 5/10 over here. Now, some of you, and I hope most of you, astutely are noticing something here. Those aren't reduced, are they? Those aren't reduced. It would be nice to reduce those and then see how we get a common denominator, all right? Should we need to get a common denominator? We might reduce it to the exact same denominator. You never know. So let's take a look at that. 8/16, well, that's 1/2. That's 1/2, isn't it? Divide both sides by 8. That gives me 1/2, 1/2. What about this little guy over here? I see 5 and 10. I know 5 will go into both of those. How about it? So let's divide 5 into both numerator and denominator. Oh my goodness. You remember I told you it might be a trick question? Here it is. Here it is. No greater than here. These are equal. They're equal to each other. So in this case, which fraction is greater? How about it? Neither. Neither one. Neither is greater. They're equal. And just again, it's another way you think about it. How do we write 1/2? There's so many ways we can do it. Depends on what you choose for your denominator. All right? There's so many ways to write a specific benchmark fraction based on whatever you put in that denominator. It's going to alter the numerator also with it, okay? That's what I want you to see from these initial exercises. So let's advance this a little bit one more time. Let's do one more here. We've got 3/4 or 9/16. This one is back to kind of an easy street. We've got 3/4. We got 9/16. And remember what I said a minute ago, something about the fact that you could divide 4 into 16 evenly. That means you need to leave 16 alone, all right? Always look at these numbers to begin with and ask yourself, will they divide evenly? If not, then play with it. You're going to have to find something different than those two numbers for a common denominator. But here, you've got a nice match with 16 because 4 will go in there. Yeah, 4 times. You knew that. 4 times. Now, where else do we put a times 4? You got it over there at home? All right, everybody thinking? Put a times 4 right up there. Life will be good. Ooh, this one's a little bit more dramatic than some of those. This one's not a really close call at all, is it, everybody? You have, looks like 12/16 versus this 9/16. So this side really wins out. It is the greater of the two. So we'll go along and say 3/4. Now think about it just a little bit. This is a little bit more than a half. This, if we had 8/16, that would be 1/2, which we just had a minute ago in our last problem. But when we look at 9/16, it's a little bit more than a half. This one's 3/4. It's a lot more than a half, all right? So definitely this pulls further to the right, and 3/4 is further to the right on a number line versus your 9/16 or 9/16, all right? So that's our story. Hopefully you're getting some good answers. Everybody 100% out there? If not, hopefully you're real close to it. Now let's stretch things a little bit, all right? Let's stretch it out a little bit. How about it? Let's see what our next problem is going to ask us to do. It says arrange the fractions in order from least to the greatest. All right, we've got a lot going on here. 4, 1, 2, 3, 4 fractions going on, and they're all looking different. So you write them down at home, write them down, and we'll order them here in just a minute. I'm going to put a 1/3. I'm going to put 5/12. I got 1/2, and I got 1/4. Wow. That's quite a range. That's quite a range. And some of you going like, well, Ernie, you said all the denominators have to be the same. It's exactly right. So let's start looking at these numbers. First of all, I'm noticing something about 2. 2 will divide into 12 evenly, so 12's a good number right now. It's in the running, all right? Will 4 divide into 12 evenly? My goodness, it'll divide into 12 evenly. Still 12 is the running choice here. Will 3 go into 12? Absolutely. All of them go evenly, so guess what we're looking for? We're wanting to make 12ths out of everything. That's going to be our common denominator. That's what we're looking for. Now, had I messed you up, if I put a 6 in it, no, 6 would be fine. We'd still have 12. Again, we're looking for numbers that each denominator will divide evenly into, and we really want the smallest one because, you know, it gets larger and larger, we tend to make mistakes. Ernie Roberts will make a mistake or somewhere, all right, with multiplication or division. Got to be careful, got to be careful. So we like to keep those numbers small. It's just easier for all of us to work with. So let's see what happened. On this 12, it looks like we multiplied by 4, didn't we? So we want to make sure we multiply that numerator by 4. I'm going to go ahead and put the 4/12 right there. Hopefully you all seeing it going on. 5/12 didn't change a bit. Leave it alone. Leave it alone. No need to mess with it. So, well, it's like 12 times 1, isn't it? That's how we did it. Now, what about here? We're multiplying by 6. So that means we do the numerator by 6. It's going to give us 6/12. Now that makes sense. That's 1/2. 6 out of 12. That's a half. That's a half. How about the last one here? Looks like we multiplied by 3. And that's going to give us 3/12. All right. So now, remember what I said. When we get the numerator, no, when we get the denominators all the same, right? Got those denominators all the same. Now we can compare these numerators, and they're all 1 unit apart. So we know, if they'll drop out my lower third for me there, guys, we notice that 3/12 comes in first. Then comes 4/12. You say, well, that makes sense, Ernie. They're numbered in order. Exactly, exactly. And we go to 5/12 and 6/12. But let's go back. That's nice, but that's not really what we were asking. We wanted to get these 4 in order. We want to get these 4 in order. So here we go. 1/4 starts us off. in order. Next one is 1/3. The next one, 5/12, right? And last but not least, you got it, 1/2. That is your final order of these guys right here, okay? Whew, right through me it went, but that's the idea. Getting common denominator, then comparing the numerators after you adjust them. Remember, whatever you do to the numerator, you got to do the denominator. Whatever you do to the denominator, you got to do the numerator. It works that way because that's how fractions are fun. You can reduce them or you can expand them. How about that? Expand fractions. I think you can do that. Hey, thanks for tuning in this afternoon. Summer school's been fun. Hopefully you got a good comparing with fraction action. We're going to do some more fraction action. We will see you next time.